So, okay, next we discuss problem number 10. It says the distance between 1, 2, 3 planes in a cubic crystal is 368.4 angstrom. What will be the distance between 4, 4, 5 planes? Okay. So, we know for cubic crystal, so for a cubic crystal we know DHKL is A by square root h square plus k square plus L square, right? And DHKL is given for 1 to 3 plane. Okay, here or given DHKL for 1 to 3 plane is 368.4 and H is 1, K is 2 and L is 3. So if we put if we substitute the value of D, H, K and L, we get the value of A, and then this value of A we will substitute for the next for solving the next phase. Okay. So now we put the values. So we get 368.4 is A by square root of 1 square plus 2 square plus 3 square. So we get A by square root of 14. So the value of A we get 368.4 times square root of 14. This is in angstrom unit. Okay, so this is the value of A we have got. Now for D, for 4, 4, 5 planes, the distance, if we say DHKL 4, 4, 5, then we can write DHKL 4, 4, 5 is A by square root of 4 square plus 4 square plus 5 square, and the value of A we have just calculated. Now we substitute the value of K. So if we substitute it, we get 368.4 times square root 14 by square root of 57, right? So if we calculate this, we get the value of DHKL 445 is 182.58 angstrom. Okay. So this is the value of or this is the distance. So the distance between, therefore we can write the distance between four, 4, 5 planes is 182.58 angstrom. Next we move to problem number 11. It says the third order diffraction angle of a X-ray beam where lambda is given 1.54 angstrom from 112 plane of silver crystal is 45 degree. What is the unit cell of the crystal? Okay. So we know from Bragg's equation, n lambda is 2d sin theta. Here n is 3. Okay, this is third order. So for third order diffraction angle, n is 3. Okay. Now we substitute and theta is here theta is 45 degree. Now we substitute, and lambda is also given 1.54 angstrom. Okay, so these are the things given here. So we write now 3 times 1.54 angstrom gives twice d times sine 45 degree. Okay, so we get d is 3 times 1.54 by 2 sine 45 degree. This is in angstrom. Okay, so if we calculate this, we get 3.27 angstrom, right? So this is the value of d we have got. Now for a cubic crystal, again for a cubic crystal, DHKL is A by square root of h square plus k square plus l square, right. So we got the value of d, okay, and for 1, 1, 2 planes, h is 1, k is 1 and l is 2. So we substitute the values now, okay. So we get 3.27 equals to a by square root 1 square plus 1 square plus 2 square. So we get a is 3.27 times square root of 6. So we get the value of a is 8.01 angstrom. Okay. Therefore, the unit cell length of the crystal is is 8.01. Next we move to problem number 12. It says that the diffraction angle of a beam of X-ray lambda, where lambda is 1.20 angstrom from 102 plane of an FCC crystal of an element is 76 degree. The density of a crystal is 2 times 10 to the 4 kg meter raised to the minus 3. What will be the atomic weight of the element? Okay. So we start with Bragg's equation. Okay. From Bragg's equation, we know in lambda is 2d sin theta. Now for n, nothing is given, so we can consider n is 1. So given n is 1, lambda is 1.20 angstrom, and theta is also given 76 degree. So we write, so therefore we can write 1 times 1.20 angstrom is 2 times d times sine 76 degree. So from there now we can calculate the value of d. So value of d will be 1.20 by 2 sine 76 degree. So if we substitute everything, we get the value of d is 0.62 angstrom. This is the value of d. Now for a cubic crystal, DHKL is a by square root of h square plus k square plus l square. right. Here H is, so for 102 planes, H is 1, K is 0 and L is 2. So, we can write D102 is A by square root of 1 square plus 0 square plus 2 square, and D102 the value we know. So, we can write 0.62 is A by square root of 5. So, we get the value of A. A is 0.62 times square root of 5. This is in angstrom. So, this is the value of A, or if we further simplify, we get the value of A is 1.39 angstrom. So, this is the value of A. Now, the given element forms FCC crystal, right? It is written. Okay. So, the given element forms FCC crystal. Therefore, Z is 4 here, right, for FCC crystal. Now, density of the crystal if we say D or rho here, Z times m by Na, Na is Avogadro's number times a raised to the 3. So, where Na is the Avogadro's number. Okay. Now, we know the density is given. So, 2 times 10 to the 4 kg meter raised to the minus 3, Z is 4, m we need to calculate, m is the atomic weight of the element, and Na is 6.023 times 10 to the 23, and value of A we know 1.39 in angstrom cube. So, if we multiply it with 10 to the minus 10, so we get meter cube. This is in meter cube. So, if we calculate this one, we get the value of m is 8.087 times 10 to the minus 3 kg, or we can write m is 8.09 gram. So, this m is the atomic weight of the element. So, therefore, the atomic weight of the element is 8.09 gram. Next, we discuss problem number 13. An X-ray beam with wavelength 4 angstrom is diffracted from 111 plane of a simple cubic lattice of unit cell length 9 angstrom. What will be the angle of incidence? Assume the order of diffraction is 1. So, here n is 1. Okay. Again we use from Bragg's equation, we know n lambda is 2d sin theta. Okay, and here n is the order of diffraction, and the value is 1. Lambda is given, lambda is 4 angstrom. So, we can again the plane is 111 plane. Again we know for a cubic lattice or cubic crystal, DHKL is A by square root h square plus k square plus l square for 1 1 1 planes, H is 1, K is 1 and L is also 1, and unit cell edge length is also given. Okay, so the again the length of the unit cell A is also given. It's 9 angstrom. So we can write D111 is A is 9, then H is 1, so 1 square, K is also 1, 1 square plus L is also 1, 1 square. So we get D111 is 9 by square root of 3. So if we calculate this one, we get roughly 5.20 angstrom. So this is the value of D. So we got the value of D, we know the value of N, now we know the value of lambda. If we substitute all these values in the Bragg's equation, we can calculate the angle theta. Okay. So now we use those here. So N lambda is 2D sine theta. Now N is 1, lambda is 4 angstrom. Then 2 times D is 5.20 angstrom, then sine theta. So the value of sine theta is 4 by 2 times 5.20. So if we get, what will be the value of theta? Theta is sine inverse 2 by 5.20. 2 and 4, they cancel each other, so we get 2 here. So this is the value of theta. So theta will be your 22.63 degree. Therefore, the angle of incidence theta is 22.63 angstrom. Next we move to problem number 14. In a CCP arrangement of a mixed oxide, divalent A occupy 1/4 of tetrahedral void and monovalent B occupy octahedral void. What will be the formula of mixed oxide? Okay. So in a CCP system, the number of atoms per unit cell is 4, right. So the number of tetrahedral voids is 2 times n, so we get 8, and the number of octahedral voids is n is 4. As 1/4 of the tetrahedral void are occupied or is occupied, tetrahedral voids is occupied by A2 plus, because this is divalent, right. So that's A2 plus ion. Then the number of A2 plus ion in an unit cell. So 1/4 is occupied. Okay, so per unit cell we have 8. So 1/4 times 8. So we get 2. Okay. Similarly, the octahedral void is occupied by B plus ion. So, the number of B plus ion is 4, right, because monovalent B occupy octahedral void. Okay. So, this is 4 here. Okay. So, to balance the charges, because we need to balance the charges here. Okay. So, to balance the charge, the number of oxygen, let us say, is x. Okay. Therefore, 2 times 2 plus 4 times 1 minus x times 2 gives 0. So, the value of x, so 2x we get 8, right. So, x we get 4. So, the number of oxygen atom or ion will be, so x here, right, and here the charge of oxygen O2, O is 2 minus, oxygen means O2 minus. So, we get x is 4. Therefore, the formula of the metal oxide will be A2 B4 O4, right. So, we get A B2 O2. This was an interesting problem. Now, next problem is what will be the percentage of Fe2 plus and Fe3 plus in Fe 0.940 crystal. Okay. So, let us consider that each Fe 0.940 has Fe2 plus ion is x and Fe3 plus is 0.94 minus x, right. Fine. So, therefore, each Fe 0.940 has each Fe atom of has 2 oxygen atoms. So, total charge, therefore, the total charge of the cation in Fe 0.940 is 2 times x, because we have Fe2 plus is x and Fe3 plus is 0.94 minus x. So, plus 0.94 minus x times 3, right. So, this is the total charge of the cation in Fe 0.940. Okay. Now, total charge, again the total charge of the anion in each molecule of the crystal is -2, right. Therefore, or so we can write 2x plus 3 times 0.94 minus x minus 2, because this is neutral. Fe 0.94 O is neutral. Okay, so we can write, if you now calculate, so we get minus x is 2 minus 2.82, and we get the value of x. So x is 0.82. Therefore, the percentage of, we need to calculate the percentage of Fe2 plus and Fe3 plus. Therefore, the percentage of Fe2 plus in Fe 0.94 O crystal is 0.82 by 0.94 times 100, right, because x is the, each Fe 0.94 O has Fe2 plus is x and Fe3 plus is 94 minus x, right. So the percentage of Fe2 plus in Fe 0.94 O crystal is this, and then if we calculate this one, we get 87.2%, and the percentage of Fe3 plus ion is, or Fe3 plus ion in Fe 0.94 O crystal is 0.94 minus 0.82 times 100 by 0.94. So if we calculate this one, we get 12.8%. Next, we discuss problem number 16. What will be the packing efficiency of the two-dimensional square unit shown below? So this is the square unit shown here. So for a two-dimensional structure, each corner of the square is shared with four unit cells. And atoms or atom inside the square is not shared at all. Therefore, number of atoms per unit cell will be 4 times 1 by 4 plus 1, so we get 2. Now again, each atom has an area of pi r square. Okay. So this is r here, okay, and if we draw a line like this, so this is also r, so this is like this, so we get r here and r here. Okay. So area is pi r square, therefore one atom will have area equals to twice pi r square, right. the area of square unit cell so square this length is given a here, so square the area of the square unit cell is a square, right. Now from the image okay, so we can just write it like this is point A, this is point B, this is point C, and this is point D, suppose. So from the image we can write AB square plus BC square is AB square plus BC square is AC square, right. Right. So we can calculate AC. AC is, this is Pythagoras theorem. Okay, AB square plus BC square equals to AC square. So we get AC square is A square plus A square, because AB is A and BC is A. So we get the value of AC. So AC is square root of 2. A square root of 2. This is the value of AC. Okay. Now what is AC? AC is 4R. You see from the diagram what is the value of AC? AC is 4R, 4 times R, because this is R, again this is 2R and this is R. So 4R is A square root of 2. So from there we can calculate A. A is 4R by square root of 2, or we can write the value of A is 2 square root 2 times R, right. So we got the value of A. Now we can calculate packing efficiency. Okay. So the packing efficiency, therefore the packing efficiency is twice pi R square by A square times 100. That gives you percent wise. Okay, this is percent. So twice pi R square times 100, and the value of A we just calculated is 2 square root of 2 times R square. Okay, so if we calculate this, we get 0.785 times 100%. So we get 78.5%. Okay, therefore the packing efficiency is 78.5%. Next we move to problem number 17. The volume of a cubic cell is x centimeter cube and unoccupied volume of the cell is 26%. If the radius of each atom is 0.3535 x raised to the 1 by 3 centimeter, then number of atoms per unit cell is, this is multiple choice question, but we need to carry out this one. Okay. So volume of unit cell is A raised to the 3 equals to x centimeter cube. Again 26% of the cell is occupied. Therefore, the packing efficiency is 26 is unoccupied. So therefore, the packing efficiency is 100 minus 26%. So we get 74%. Okay. Here, the radius of each atom is 0.3535 x raised to the 1 by 3 centimeter. So, packing efficiency you can write this z times 4 by 3 pi r cube by a cube times 100, and the packing efficiency value we know 74. So, 74 is z times 4 by 3 pi r raised to the 3 by a cube times 100. So, we now substitute the values. So, we get 74 and then we write z times 4 by 3 pi r cube. Okay, so, times pi, value of r is given 0.3535 x raised to the 1 by 3 by value of a cube is also given x times 100. So, the value of z is, if we calculate, we get z is 4.00. Okay. Therefore, the number of atoms in the unit cell is 4. So, B is the correct option. Next, we discuss problem number 18. It says, in a FCC crystal lattice, A occupies the corners of the unit cell and B occupies the face of unit cell. If one B is missing from the face, then what will be the formula of the compound? This is an interesting problem. So, the crystal is face centered crystal. Thus, the crystal is face centered cubic crystal. A or element A occupies corners and B occupies face center of the crystal. Therefore, the number of A per unit cell will be 1 by 8 times 8, right. So, you get 1, and the number of B per unit cell is 6 times 1 by 2, so you get 3. Now, 1 B is missing from the face, right. Again, 1 B is missing from the face. Therefore, the number of atoms of B, the number of atoms B per unit cell is 5 times 1 by 2. So, you get 5 by 2. Therefore, the ratio of A and B is, if we say this is A is to B, is 1 is to 5 by 2. So, we get 2 is to 5. We need to calculate, we need to calculate the, or we need to determine the formula. Therefore, the formula of the compound is A2 B5. Next, we discuss problem number 19. Fe iron makes a BCC crystal with unit length 0.3 nanometer, if the density of iron is 7.8 grams per centimeter cube, then what will be the number of atoms in 26 gram of Fe? The unit cell length of Fe crystal if we say this is A, this is 0.3 nanometer, it is given. Density of Fe, the density of Fe is 7.8 grams per centimeter cube. And if we, this is nothing but a rho. Again we know rho is Z times m by Na times A to the 3. Here Z equals to 2 for BCC, right? We know those things. Okay, so now we substitute the values. So 7.8 grams centimeter raised to the minus 3 is 2 times m, and Avogadro's number, Na is the Avogadro's number, we know. Is 6.023 times 10 to the 23, and value of A is also given 0.3 nanometer. So we can calculate this as 0.3 times 10 to the minus 9 meter, right? So we can write this as 0.3 times 10 to the minus 7 centimeter. So because we are considering in centimeter unit, because density is given in centimeter unit. Okay, so grams per centimeter cube. So rho is A is 0.3 times 10 to the minus 7. This is centimeter cube. Okay, so now we can calculate value of m. So value of m will be 7.8 times 6.023 times 10 to the 23, and you get 21 here, so you get 10 to the 22, sorry 10 to the 2, and 0.3 is to the cube, this is cube, okay, by 2. So if we calculate this, the value of m we get 63.4 grams per mole. So this is the value of m, okay, or atomic mass we have got. Now we need to calculate what will be the number of atoms in 26 gram of Fe. Okay. So again 63.4 gram of Fe contains Avogadro's number, right? Contains 6.023 times 10 to the 23 number of Fe atoms. Therefore, 26 gram of Fe contains 6.023 times 10 to the 23 times 26 by 63.4 number of Fe atoms. So if we calculate this, we get 2.47 times 10 to the 23 number of Fe atoms. Therefore, the number of Fe atoms in 26 gram of Fe will be 2.47 times 10 to the 23. Next we move to problem number 20. It says, in a CCP arrangement, the number of unit cell is n. What will be the number of tetrahedral voids? Here the number of unit cells in a CCP arrangement is n. In a CCP arrangement, the number of atoms per unit cell is 4. We know this. Therefore, total number of atoms is 4 times n. Now, the number of tetrahedral voids is 2 times number of atoms so you get 2 times 4n, so you get 8n. Therefore, the number of tetrahedral voids will be 8n. Next we discuss problem number 21. It says A and B forms a crystal. B forms crystal of CCP arrangement and A occupy 1/3 of the tetrahedral void. What will be the formula of the compound? Given B forms CCP structure and A occupies the 1/3 of the void, tetrahedral void. The number of atoms per unit cell in CCP, if we say n, so n is 4. Therefore, the number of B atoms is 4. So, the number of tetrahedral voids is 2 times n. So, 2 times 4 we get 8, right. So, therefore, the number of A per unit cell is 8 times 1 by 3. So, we get 8 by 3. Therefore, the ratio of A is to B is 8 by 3 is to 4. So, we get 8 is to 12. So, we get 2 is to 3. Therefore, the formula of the compound is A2B3.